In the simulation, we look at the case where we have a binary mixture that we're feeding to a drum, and we can control the composition. In this case, the mole fraction of feed is 50-50, so 5 moles of methanol, 5 moles of water at relatively high temperature. We flash to 1 bar pressure, and we can control this pressure also with a slider. And then we do the material energy balances to determine the temperature, to determine how much vapor, and then the composition of the vapor phase and the composition of the liquid phase. So this gives the mole fraction of methanol in the vapor, the mole fraction in the liquid. And then the bar graph is used to give you a better visual representation of how many moles are in the liquid phase of each component, how many moles are in the vapor phase. And so the vapor is enriched in methanol, which is the more volatile component. This is just ideal solution, Raoult's law, but we have to do a material balance on each component and apply vapor-liquid equilibrium in order to determine this temperature, these compositions, and then the amounts of each phase. And the simulation allows us to see the effect of changing the feed temperature, changing the mole fraction of methanol, and changing the pressure of the flash drum. So now let's look at this interactive simulation. So here's the interactive simulation where we can change the mole fraction of the feed, and you can see that's reflected in the moles here changing. We're feeding a total of 10 moles, and it's reflected in that the moles of vapor and liquid and their compositions change. We can change the pressure, and as we raise the pressure, notice we raise the temperature and we have less vapor formed. So lowering the temperature, more vapor. And then we can raise the feed temperature, and that also results in more vapor. And so this idea of going through a flash drum, we can see we get some separation. We get a higher concentration of methanol in the vapor phase than in the liquid phase. And the split between the two is a function of the energy balance, the mass balance, and vapor-liquid equilibrium. In this case, Raoult's law for ideal solution.